Okay, so ISN page, whatever. If you're putting in your ISN or not, it doesn't matter. Just left that on there. So the first thing we're going to look at is the nonlinear equalities with the polynomials, because that was one of two things that you had to do. Here's step by step, kind of like what you would see from those notes that you had. You always want to set it equal to 0, create a sign chart. Now this is the step that I didn't see in y'all's instructions. You don't have to do, like, you can do what it said. They kind of created a table, but I think this way, for me, it's easier to kind of wrap my mind around everything. And then we're going to test values, and we don't care about the exact numbers. We just care about whether or not things are positive or negative. And then we're going to interpret it, and then it says be sure to write your answer in interval notation and think about the endpoints. Okay, so I will cover all of that as we go through some examples. So nicely, this first one is factored for you. I think that everything you've had, have they all been factored for you in this situation? It seems like the ones I've seen. I don't know if you recognize that or not, but we need our zeros, okay? So our zeros here, x equals, so I have an x equals 3, -1, and 4. Y'all agree with that? We're just getting the zeros from our polynomial. Then we're going to create a sign chart. It's like a number line. You don't have to put every single number on it. You just need to put those in order. The spacing doesn't matter either. I kind of space them evenly because I think it makes it easier, but I have 3 zeros. So I'm going to have -1, 3. Oh, wait a minute. Oh, that should be a -4. Dang it. Y'all are clearly not paying attention because you didn't stop me. Should be a -4, correct? 3, -1, -4. All right, so we got -4, -1, and 3. And then we're going to test values. Remember, all I care about is what am I getting, if it's what I get, positive or negative. That's it. I have 3 places to plug those in. So if I choose something between -infinity and -4, like -5, -5 minus 3 is negative. -5 plus 1 is negative. -5 plus 4 is negative. So I'd have a negative times a negative times a negative. If I multiply 3 negatives together, what do I get? Negative, which makes that negative overall. Okay? Between -4 and -1, I can choose -2. It just has to be between the two. So -2 minus 3 is a negative number. -2 plus 1 is a negative number. -2 plus 4 is a positive number. When I multiply negative times negative times positive, what do I get? Positive overall. Then I pick between -1 and 3. If I can pick 0, I'm going to pick 0 because that helps. So 0, that would just give me a -3, a +1, and a +4. So that gives me negative overall. Then if I choose something between 3 and infinity, like 4, that would give me positive, positive, positive. That's positive overall. The other thing that I need to pay attention to is this sign right here. Like, what is it asking me for? Greater than 0 means I'm looking for positive, but that does not include the zeros. So here, these have to be open circles. Okay, open circles there. And then I want the positive values, so that's this part and this part. So that tells me the function is positive from -4 to -1. I do not include either one because my circles are open. And then from 3 to infinity. Okay. What questions do you have? Yes, sir.
Can you just go over like the number line real quick about like negative, and positive?
Okay, so I'm picking a number, right? I'm picking like -5, something between -infinity and -4, right?
Yeah.
I'm gonna substitute it in here. So -5 minus 3, that's a -8. The 8 part I don't care about. I just care that it's a negative number. Okay. That's what I meant by that. I'm sorry, I went through that too quick. Thank you for asking. What else? Anything else? Yes, ma'am. Because this is not included here. Just like like if you're going to shade a number line, and that's why. Does that make sense? So over there, it's going to be closed. Yes.
How do you know you're looking for the positive?
Because it's great. I want this to be greater than 0.
Oh.
And if it's greater than 0, it's positive. Good questions. Those are important little things. Anything else? Okay. Let's try example 5 then. And see how this alternated like this? That doesn't necessarily happen every single time. So from here, it's factored. My zeros, I get x equals -2 and +5. So on my number line, I'm going to have a -2 and a +5. Okay. So I have to pick a number from -infinity to -2. One of the common mistakes, guys, is forgetting the ends, like just doing the middle part. Don't forget about the stuff on either side of them. So between -infinity and -2, I can pick -3. So -3 plus 2 is a -1. It's a negative number, but I square it. You see how this is squared? So since I'm squaring it, it's going to be positive. So no matter what I substitute into the first one, I'm going to get a positive number out. You with me on that? So then so when I substitute it in there, it's going to be positive. Then a -3 minus 5, that is -8, but all I care about is the fact that it's negative. And then a negative times a positive, that makes that negative overall. Right? Then between -2 and 5, I can pick 0. Well, no matter what I put in here, it's going to be positive. Then 0 minus 5 is negative. That makes that negative overall. Between 5 and infinity, I could pick 6. The first one's positive no matter what. 6 minus 5 is a positive number. That's positive overall. Now, I double check my sign over there, and this says less than or equal to 0. That means it's negative or 0. And since that has that line underneath that, these are closed because we're including them. Okay? And so I've got, if I want it to be negative, it's negative here and here. But I'm not going to put it in as two different intervals because that will that would be counted wrong because we're including it. So really, I can just go straight from -infinity all the way to 5. And do I include the 5? Yes. Okay. If this was an open circle, then it would be from -infinity to -2 and then -2 to 5. But it's a closed circle, so I get to just go right on through. Okay. What questions you got? Okay. Now, when we do rational inequalities, which is what we're about to do here, you have to use both the zeros and the undefined values. Okay, that's what makes it a little bit different here. So again, we make sure that, I mean, you kind of say solve for 0, but you're not really solving it. But make sure the inequality has a 0 on the other side, that everything's on one side. Make sure you have a single rational function. I don't think y'all had any where you had to combine your rationals, so I think you're fine on that. And then we set the numerator and denominator equal to 0. So here's some rational information before we even worry about any of the rest of the stuff. The numerator of the rational gives you the zeros of the function. So if I set x minus 2 equal to 0, I get that x equals 2. Okay, that's the zeros of the function, right? That's something y'all had to find and had to plot on those graphs. When you find the zeros of the denominator, those are your vertical asymptotes. So I have a vertical asymptote at x equals -6 and at x equals 3. Okay, that's the information. You have to have your zeros and your vertical asymptotes to do this. Now, something you don't need, but I'm going to ask you because I want to talk about rationals, is the horizontal asymptote. For this rational function, to figure out horizontal asymptotes, we look to see if it's top heavy, bottom heavy, or tied in degree. What is this one? It is bottom heavy, because this would be an x squared in the denominator and x in the numerator, right? Since it's bottom heavy, your horizontal asymptote would be at what? Y equals 0. Okay, that makes sense? Again, not something you have to find for the inequalities, but because we're also talking about rationals, I want to get that in there. All right, we good so far? All right, so then I'm going to, so on my number line, I have to put my zeros and my asymptotes. So I have 3 things to put on here. I've got -6, 2, and 3. And one of the things I skipped over for whatever reason, be careful to mark values for h of x, or this is the denominator, or the denominator equals 0, we never include those values. Those are your vertical asymptotes. Okay? And then we're still going to test them to see if they're positive or negative. So let me tell you what that means. That means this. This right here says greater than or equal to 0. That means that my circle should be closed, but that only close it on this one. Your asymptotes have open circles no matter what is going on with that sign. Okay? Asymptotes, you are never including. They are always open. It's only the zeros that depend on whether that is opened or closed. Okay? Does that make sense to you? Anybody have a question about that? All right. Never closed, always open. Well, yeah, it's because you can't. So these are open or closed based on whether I want to include 0, and like 0 is an actual number, but you cannot cross a vertical asymptote, so you'll never be able to include it. Does that make sense? It's like, okay. Good question. Anything else? All right, and then we do really the exact same thing, is that we're going to look at, but we have to substitute it into the numerator and denominator. So between negative infinity and negative 6, let me pick negative 7. So negative 7 minus 2, that's a negative number. Negative 7 plus 6, that's a negative number. Negative 7 minus 3, that's a negative number. And then when I do it for myself, I stack them like they're stacked there just because it makes, that way I make sure I've done everything and didn't do too much. But either way, whether I'm multiplying or dividing 3 negatives, it's going to be negative overall, right? Then between negative 6 and 2, I can pick 0. So the numerator will be negative, and then I have positive, negative down there, which makes that positive overall. Between 2 and 3, well, I'm going to have to pick like 2.5, but it will be fine. 2.5 minus 2, that's still a positive. 2.5 plus 6, that's positive. 2.5 minus 3, that'd be negative. Like, you don't have to do the actual math. You just need to know, are you going to get a positive or negative number? And then between 3 and infinity, we can go with 4. That'll give me positive in the numerator, positive, positive, positive overall. And then I pay attention to what I wanted. I want this function to be greater than or equal to 0. So that means I'm looking for positive, and I'm positive here and here. So I'm going from negative 6 to 2. Do I include the negative 6? No. Do I include the 2? Yes. And then I start back over at 3 and go to infinity. Do I include the 3? No. Do I include the infinity? No, never. And that's what it looks like. Okay. What questions you got? Yes, sir.
Why'd you include the 2 again?
Because this is closed.
Oh, okay.
So whether this is open or closed depends on whether the zeros get opened or closed. These are always open. Okay, good question. What else we got? Anything? All right, so then we're good. All right, then over here, I want you to factor that. I left one on to make you factor. What do you call the numerator? What's happening there? Even if you don't know what it's called, you should know what to do. Difference of squares, yeah. What did you say? Well, the 2 terms have to be perfect squares, so I mean, yeah. But there's something else called a perfect square trinomial, and that's actually what the denominator is, but we'll get there in a minute. So can y'all factor that without me? Knock yourself out. Factor it. That's what I got when I factored. Do y'all agree with that? Because the numerator is a difference of squares. That's easy to factor, but then I can clean it up a little bit. X plus 2 times x minus 2 greater than 0. The denominator, I have 2 of these. This is x minus 5 squared. So this right here is actually what you call a perfect square trinomial, because you take something and you square it. But again, knowing the names of them, not as important as knowing how to get the right answer. And if you don't recognize the pattern, that's fine. You get there, and then we make it into that. Okay? Everybody good so far? All right, so then I need my zeros from the numerator. Actually, I guess I'm coming from that numerator. Let me redo that. My zeros come from here. So my zeros are going to be x equals what? 2 and negative 2. And then from here, I'm getting a vertical asymptote. And that'll be at x equals 5. Everybody good with all that? Now on this one, horizontal asymptote, is this top heavy, bottom heavy, or tied in degree? Tied in degree. So this asymptote would be y equals what? 1. Good. Because you'd put the 1 over the 1, you get 1. Again, you don't have to find the horizontal asymptotes for these questions, just talking about it because of rationals. All right, so I'm going to make a number line. And on there, I have 3 things to put on there. I have a -2, a +2, and a 5. And remember, it does not matter. They don't have to be spaced evenly. They don't have to be spaced accurately. Just put them on there. All right, so then I'll put in a -3. Now, this is the one that I want to look at here, because this is the one that has the squared in it. It's all simplified. That's the one I'm using. I could use that one, but it would make it yucky. I'd have to do a lot of work. And then that one, I'd have to think a little bit harder. So I'm using this one. If I substitute in a -3, the numerator is going to give me negative, right? But because the denominator is squared, it does not matter what I put in. I'm going to get a positive out of that every single time. So I don't even have to think about the denominator. So all that together gives me what? Negative or positive? Positive. Between -2 and 2, what would you pick? 0, absolutely. So then in the numerator, I'd get positive, negative real easily. Denominator's positive no matter what. Negative overall. Between 2 and 5, I'd probably pick 3. So that would give me positive, positive, positive. That's positive overall. Between 5 and infinity, I could pick 6, and that will give me positive, positive, positive. And once again, it's positive overall. And notice that the example 1 to the left, it went negative, positive, negative, positive. Sometimes it alternates. This didn't alternate between positive and negative. And it has to do with the square. But if you understand how it works, that's great. If not, do your sign chart and it won't kill you. Because I don't want to make it more complicated than it needs to be. But I need to look at my circles. Okay, I know that this one, oops. Okay, hang on. I know that this one has to be an open circle because it's an asymptote. Are my zeros opened or closed? Open. They're open because there's not a little line underneath it. Okay, yes? All right. Everybody good so far then? And if this says greater than 0, what am I looking for? Positive. I'm looking for positive. That's here, here, and here. So like here, here, and here. So that I know that I'm going from negative infinity to -2. Do I include the -2? No. Then I start back over at 2. Can I go all the way to 2 to infinity since these are both positive? No, because that is open. So I have to go from 2 to 5, and then from 5 to infinity. What questions do you have? Very good question. Why couldn't I do that on the other one? So let's look at this one again. I had to, this is only greater than, it's not greater than or equal to, so I have to skip over 5. On this one, right here, when I wanted both of these and they were both negative, because I was including this 0, I got to go straight to 5. Does that make sense? And that's the part that can be confusing. That's why I think the number line helps, and you literally putting your open and closed circles on there. So you think about that before you start writing your intervals, and you don't get all confused in that because it can get confusing. Yeah, exactly. Because if this means less than or equal to 0, so I get to include these and the literal zeros themselves. If it looks like this, it's only when it's greater, only positive. The zeros don't count, so I have to skip over those. Okay, we good on that? What questions you got? If I didn't show you the line the other day, you kind of like the line better than whatever the heck you were doing? I don't know what was going on there, but all right. But again, now y'all are my guinea pig here. Now I know better. Next year in the first semester, this is something we need to attack. I wasn't sure what all we needed to attack, but any questions at all? Y'all got this? You got any rational questions in general? Like I didn't put a bunch of rational questions on here because I figured most of what you were doing was finding the zeros and the vertical asymptotes and the horizontal asymptotes. So I figured we could talk through it with this. But I mean, if you have any other questions individually, I'll be happy to help you. But if I need to like get up and do a whole nother lesson on it, I'll do that as well. We good so far? All right, perfect.